Hello and welcome to this lecture. In this lecture we'll be talking about Zen Framework 2's Module Manager. So, here's an introduction to the module system. It's one of the key features of Zen Framework 2, like we talked about before. It enables developers to write self-contained modules, and these are easy to basically plug and play into existing applications. Modules provide their own configuration files, and these are merged together with the entire application's configuration files. And this is done by the Module Manager. The configuration required for a module to function is provided within the module itself, so you don't have a lot of central configuration in the application itself. A module is very self-contained, and as such there's no need to configure an application's configuration files in order for the module to integrate with the application. All you have to do is to make a single change in the configuration just to enable the module. But this is just a simple key in an array, so it's one line. So now we'll talk a bit about how to configure modules. So modules are configured within a module.php file, and this file includes a class which is called module. So below we have some methods which return arrays that configure a module. So the first one that I'll talk about is one that's called getAutoloaderConfig. What this does is that it returns an array that configures autoloading of the module's source code, which is usually found within the src directory, but we'll see that a bit later on. The next one is the getConfig method. This basically provides the general module configuration. This could be routing and so on. Then there's the getServiceConfig. This is basically equivalent to configuring the service manager under a service manager key in getConfig. So what this does is that it provides configuration for the service manager. We'll get back to what the service manager is in a later presentation, so don't worry about that for now. So these methods are automatically invoked by the module manager when each module is enabled and configured. You can also implement these interfaces: Autoloader provider interface, config provider interface, and service provider interface, instead of just declaring these methods by convention. You can actually choose which approach you like the most, but in my personal opinion, I like implementing these interfaces because then I'm not relying on a convention that new people to the framework won't necessarily know about. So, let's talk a bit about the module manager. The module manager is responsible for loading the module within the application, and it does so by iterating through those that are defined in the application's configuration file. And this file, by convention, is stored within the config folder and is called application.config.php. Internally, Zen Framework 2 triggers a sequence of events for each module, and you can actually subscribe to these events to configure the module, to add some custom logic when certain events happen. And actually, Zen Framework itself subscribes to these events, but we'll get back to that when we'll talk about the event manager. The module classes found within module.php, they are instantiated, and the configuration methods that we talked about on the previous slide, they are invoked. So this configuration that is returned by these various configuration methods is merged into the main application configuration by the module manager. So we don't have to worry about this, we just have to provide the configuration that is required for each module that we implement. Actually, this makes things just a little bit easier for us as developers, so this is great. So now moving on to talking a bit about autoloading. Although Zen Framework 2 uses namespaces, the required files still need to be loaded. If you have developed for PHP for a long time, you might remember the days when we were including files by using include or require. Zen Framework 2 includes this auto-loading functionality in a way that this happens automatically for us, so we don't have to worry about requiring the files or including the files that are necessary to run a piece of code. The only thing we have to do is to specify how this auto-loading should be done. And the easiest way is by using a class called standard autoloader. And we'll see how this works in the following slide. What the module manager does is that it'll invoke a module's getAutoloaderConfig method within the module class, where it will find configuration of the autoloading. So how this works is that an autoload method is registered with PHP SPL autoload register function, and this function is invoked whenever we try to use a class that has not been loaded yet. This method adds the callable path as a parameter to the Autoload stack. This means that autoloading will actually lazily load the required files. They will be loaded when they are needed and not ahead of time. So developers can simply access classes directly, and then the autoloading will take care of the rest, which is great, so we don't have to spend time requiring files and taking care of if they have already been included and so on. So each Zen Framework 2 autoloader provides a different way of resolving the file, but they all use the above approach. So let's talk a bit about the simplest method of autoloading, which is the standard autoloader. It assumes a one-to-one mapping of the namespace plus class name to the file system. So some normalization will happen here. For example, the backslashes in the namespace will be converted to the directory separator, and the class name will have .php appended at the end of the path. Also, underscores will be replaced with directory separators. This implementation uses preg, match, and str replace internally, and this is not exactly fast. So it's useful for development, but not so much for production, because actually it's a pretty slow approach, and we don't want our production systems to be slow. So actually we will look at a faster approach in just a moment. But first, an example of how the standard autoloader can be used. So as you can see here, we have a getAutoloaderConfig method implemented. This method exists within the module class of our module, and it simply returns an array. So in the array, we define the namespace of the autoloader that we would like to use. And within an array, we configure this autoloader. So we add an array of namespaces to it, which is actually just telling the autoloader where to find our source code. We add it by the name of the current namespace, which is the namespace of our module. And we basically tell it that the source code exists within the current directory /src/ our namespace. So in this case, a namespace could be user, for example. At the root of our project, we would have an src directory, and in that directory we would have a user directory, and within that we could have controller directory, model directory, and so on. So this is all it takes to configure the standard autoloader. The rest will be done automatically for us. And now we can just go ahead and use whichever class we would like, and it will automatically be included for us. So moving on to another autoloader implementation, the Classmap autoloader. This is used to improve in performance in production environments. Basically, what it does is that it maps class names to absolute paths of the physical files on the file system. It uses a file named autoload classmap.php, and this is by convention. And this contains an array that maps a class name to an absolute path. This way, autoloading can be done very efficiently by simply doing lookup in an array. So we just look up by key into an array with the class name, and we'll get the path directly on the file system, so we don't have to do any normalization, removing underscores, working with directory separators, and so on. And something that's very handy is that Zen Framework 2 provides a handy tool for generating this class map. This is available within the Zen Framework 2 GitHub repository under the bin directory. And this is very useful because you will see that it becomes a very tedious process to write this by hand. It will take a long time and it will be hard to maintain. So here we have an example of the Classmap autoloader. As before, it's configured within the getAutoloader config method, again within the module class. What we have done here is that we have just changed the name of the autoloader, and we just pass it an array of files where we have the class maps. And like I told you before, by convention we put this in the root of the module in an autoload classmap.php file. And actually this is all that needs to be done to use this autoloader. And if we'd like, we can just return an empty array as long as we have a standard autoloader configured as well. That will take over if this fails, if a lookup fails, but I'll get back to that in a moment. So here we have an example of the contents of the autoload classmap.php file. As you can see, it basically just returns an array of class names, including the namespace. The value for each key corresponds to the fully qualified path on the disk on the file system. So as you can see, if we look up an entity within our module that's called user, immediately we'll get the path on the file system for that class. So we don't have to normalize anything. And one more thing, in addition to the classmap file, actually two other files can also be added. An autoload function.php and autoload_register.php. So the first one, autoload_function.php, it should return a callback function, which can be used together with the HPL autoload register function. And this may utilize the class map. This is basically if you want to configure autoloading, but this is for pretty advanced use cases, so for the most time you won't have to bother with this. So like I said, it allows you to use your own autoloading function. Autoload_register.php should register this callback function. And like I said before, this will typically be with the SPL autoload register function. This means that autoloading is very flexible and that it can easily be configured, and actually this is the only reason for doing this. And now I have a few tips for you. You should add both the Classmap autoloader as well as the standard autoloader. This is because if a file cannot be resolved with the Classmap autoloader, then the standard autoloader will try. And this is useful if you add the Classmap autoloader first and then add the standard autoloader. First, the Classmap autoloader will try to load the file, and if it fails, it will move on to the standard autoloader as a backup. But since the Classmap autoloader is significantly faster than the standard autoloader, this will give us a boost in performance in the case that we actually have a class map available. So this approach is very useful in development environments where you don't want to regenerate the class map every time you add or remove a file. Then the standard autoloader will just kick in and do the work for you without you having to do anything. Alternatively, the generation of the class map can be integrated into the build procedure, but this takes a bit of time to configure, and if you're just working on a small project, you might not have the time to do this. Also, it's useful to avoid errors if for whatever reason an entry is missing from the class map. It could be that you forgot to regenerate the class map. Instead of users being served with an error on your website, the standard autoloader will just take over. This can be a little bit risky because the performance of your application will degrade and you might not even notice this. But it's a nice backup to have either way. On a small site where performance is not so critical, you don't have to bother with this class map. Because when it comes down to it, you can always generate this when you need to. So let's say your small blog or whichever application that you build in Zen Framework becomes increasingly popular, and you need to increase the performance of your website, then this is something that you can do. But if it's a very small site and you don't anticipate a lot of traffic on it, then it's perfectly fine to just use the standard autoloader and accept that the performance is not as great as with the Classmap autoloader. So that's all about autoloading. You might think that this is a complicated subject, but you really don't have to worry if you didn't understand all of the concepts introduced in this presentation, because we will get back to this and I will show you how to implement this step by step. So the purpose of this presentation was just to give you an idea of how autoloading works. So thank you very much for watching, and I'll see you in the next lecture.